So in the last video, we used the rotating mask illusion or the hollow face illusion to show that at least sometimes seeing is presuming. The question is, how often? This time we'll use the McGurk effect to reiterate that perceiving is presuming, or sorry, seeing is presuming, and we'll use some related effects to talk about the more general claim that perceiving is presuming. So what is the McGurk effect? Well, the McGurk effect is an example of what's called a cross-modal effect. And a cross-modal effect is an effect in which sort of ordinary patterns of order from, say, an object in the world to light waves to your eyes to visual experience, or an object in the world to sound waves to your ears to auditory experience, fail because some lines get crossed. So now let's suppose that perceiving is absorbing, and let's just do seeing in particular. Suppose seeing is absorbing. So things work kind of this way that we described before, where you have the object in the world, your eyes absorb light waves, and your brain then sort of takes what's present in the retinal image and creates a visual experience on that basis. So your eyes are open, they allow light to enter, your retinas absorb that light, which creates a retinal image, which matches the pattern of the scene before you. Your eyes then signal your brain, which formats the retinal image as a visual experience, allowing you to see. Your eyes are a mere scribe. We're going to do the same thing for auditory experience now, or for hearing. You have an object in the world, it produces some sound waves, they strike your ear, your brain then takes that signal and acts as a scribe to produce an auditory experience that matches the sounds in the world. So sound waves strike your ears, receptors in your ears called stereocilia react to those sound waves, creating the auditory equivalent of a retinal image. Your ears then signal your brain, which formats that image as an auditory experience, which allows you to hear. Everything here lines up neatly. And what I want you to suppose for see right now is that if perceiving is absorbing, then everything should line up neatly. Your eyes absorb light, and your brain, in effect, absorbs the retinal image and puts it in a format you can use to make you see. Your ears absorb sound waves, and your brain, in effect, absorbs that sort of auditory equivalent of a retinal image and then puts it in a format that you can use, an auditory experience. And the same thing will happen for touch and smell and taste. Here's a sort of chart that illustrates this idea. You have your object in the world, maybe a cello. It reflects light waves which strike your eyes. Your brain acts as a scribe to create a visual experience. Then there's the cello, which creates sound waves, which strike your ears. Your brain acts as a scribe, producing auditory experience. Maybe you touch the cello. There's mechanical pressure on your skin. Your brain acts as a scribe, taking the signal from your skin to create tactile touch experience. There's an object in the world. Again, it can be a cello. It's breaking down a little bit, producing chemicals in the air, which are binding with your receptors in your nose. Your brain acts as a scribe to create your smell experience, your olfactory experience. And again, you have that object in the world, the cello. You lick it with your tongue. So some chemicals from the cello bind with receptors on your tongue. That your brain acts as a scribe, takes that signal from your tongue, and creates gustatory experience, that is, experience of taste. Okay, so the idea, what I want you to see is that things kind of line up neatly. We have a nice straight line, a nice straight line, a nice straight line, and so on. And it looks like the claim that perceiving is perceiving is absorbing implies that everything would line up neatly in just that way. And now what we'll do is look at the McGurk effect, which shows that things don't line up quite so neatly. Okay, so how does that work? Well, I want you to go to a YouTube video here, and or you can just search McGurk effect on YouTube and watch any of the videos. But we also looked at one of these in class. The one that we looked at was someone mouthing "that fat bat," while the audio played "bat, bat, bat." And what you would notice if you were in class last time was that it sounds to you as if the person is saying "that fat bat" when she was mouthing "that fat bat," even though the audio was "bat, bat, bat." And correspondingly, when you close your eyes, you hear "bat, bat, bat," even though when your eyes are open, you hear "that fat bat." And the basic idea here is pretty straightforward. There's crossing of lines. The stimulus to your eyes is affecting what you hear. And we'll stop this video there and explain this further next time and look at a further effect next time. But what I want you to do right now is immediately come back here and see if this is right. Given the McGurk effect, this has to be wrong. because there isn't a straight line like this, at least in the case of auditory experience, because your auditory experience is partly affected by stimulus to your eyes, so there has to be some crossover. Correspondingly, your brain can't be acting as a mere scribe. It has to figure out how to integrate the stimulus from your eyes and your ears in order to produce an auditory experience. Okay, we'll stop this video there and continue next time by talking about another effect. It's related to the McGurk effect, except instead of having what happens to your eyes influence what you hear, it will have what happens to your eyes influence your touch experience, how things feel to your hands.